To solve this model, we write only 2 lines of code. So we just say solver equals cp model dot cp solver, and this is again is syntax that we declare that it is cp-sat model solver. Also status will equal the solver dot solve model. Now status has in OR tools, status is if we got us an optimal status, it will be saved in here. Sometimes we don't have a solution, or we have error, or just simply the problem cannot be solved, we will get status in here. But once we put this one and solver.solve model, we're actually going to solve this problem. So when we put shift enter, we should be or already starts to solve this problem here. Just a mistake here, capital letter. So now it's, of course, the variables are very limited number. We don't have much, also big intervals. So the model is already solved. In order to print out the results, what we do is first we check the states or the status. If status equals cp model dot optimal, or status equals cp model feasible. So if we have if we had or have a feasible solution or optimal solution, so it's not necessarily an optimal solution, we print the results. Otherwise we just say just no solution found. We report this one. So sorry, here we have to put print. So here now, if we got the solution, and here should be like this. We say print, we will print the solution, and we will use one of collections library features or method that is called default dictionary, and we will have an input of list. That is, we will connect a number with a list. So in order to do that, we have to apply this one, because the normal dictionary connects one number with another number, or one entity with another entity, of course one string with another string also, but not with multiple. So to do that, or to append that, of course we can connect them, but to keep appending, you cannot append into a specific location. You can try it out, but it's not going to work. The only way you can do it is by first creating a list, and basically do this way: create a list and then append it, append everything in this list, and then define and then put it into the dictionary. However, let's not to do that. We just use this function, and then we can append part or element in this list. So now we go for the whole thing, for job ID, job. We want to get all the results from the OR tools. Enumerate for task ID, also task enumerate. We take also the job. Machine, well, basically the same thing. Machine equals task 0, duration equals task 1, and then we need to keep appending now the results. Machine, because as we said at the end, what we're doing is we are scheduling for every machine. Assigned jobs. Seems okay. So here we will go to that variable. This is we declared before, and we put into it all the data we want. Just, yeah. Assign task will have a start, solver, this one, dot value of, we have to go for all this one, and all tasks has all the jobs, all the tasks we have exist here. So we will refer to every variable with using this one, because we have these dotted code we don't know. So it's better to use this way, not to get lost. All tasks, and we need the job ID and task ID. Dot start. So we will refer to the variable of start, and we need the value from the solver, and this will be assigned to the start in here. Now after that, what we will take is the job equals job ID. I'm not sure if we call it job or jobs. Just a minute. Start job index, so we call it job, and then task ID is index, and then duration, so job ID, and we took the index equals task ID, and duration, well, equals duration, now a little bit better not to use the same name, just in case. So this is going to assign the values of our solution, of the solver, of the starting time for these tasks. Now after that, we just well, this is just a syntax to print the whole thing. So we will have output equals this, and then we will go for every machine. And we just print out the whole results, all machines assign jobs, this one. Dot sort, just to make sure we have it 0, 1, 2 and not else. Now we just like string task equals machine string so this is just to print, to have a beautiful kind of representation. Assign jobs, yeah, for every machine. These are just we print the, it's a little bit not so exciting, but we have to print out as beautiful as possible our results. Task underscore I and so these just name, it will call the task ID and the job ID and the task ID. And now solve the solution. We will take, like, keep printing basically the names of these ones. We put this one means space, 15 spaces. Of course, this is a little bit not so exciting, but just you can of course change it as you like, but this is just to show our results. Duration, so this is the start. We assign them, and the start time, and duration, and of course the start, if we know the start, duration will be the start plus duration. Temp, and so just a string versus start and then start plus duration. So this is all print statements to show our result. So at the end we will see how it works, and of course, like, I will not line by line explain it, because I mean it depends on you how you want to write your solution. You can also use matplotlib to have a bit better looking solution rather just a string. This is template. So finally we will print our solution, and we can see here some for job ID in data. Jobs data 35. Yeah, so now is this is just here we have to put it tasks, because we already give this number to be tasks, so it was not defined. So anyway, now we have the solution, and you can see machine 0 will do job 0 for will do job 1, which will be task 0 from our number 0 to our number 2, and then it will do job 0. That is going to be the first task of job 0, which is task 0. It will be processed from our number 2 to our number 5. Machine 1 will take job 2, task 0, from our number 0 to 4, and then will have from 4 to 5 nothing. This machine 1, it will not do anything. And then from 5 to 7, 7 to 11, it will work. Now machine 2 is going to do first job 1, task 1, but for the first 2 hours, it will not do anything. And then it will start doing the tasks from 2 to 3, and then 1 hour rest, and then 4 to 7, and then 7 to 9. And this is the machine 2.0, two tasks or schedule. The maximum time that we are going to the end time, the whole optimization is 11. So this is the minimum time required to do these 3 jobs on machine 0, 1, and 2.